have to keep my stuff in order.
Alright, so today is kind of like our one day of geometry. So all the big things that I need you to know from geometry, the big things that come up a lot, we will see again. And when they're really relevant, we'll bring it up again. But we're just trying to hit a couple key topics. If you haven't had geometry, that's okay, because I'm going to tell you everything that I need you to know. This first bit, if you had geometry, you spent a ton of time doing this, so it's probably review. If you didn't have geometry, it's probably going to be totally new, but it is not going to be a huge emphasis for us. It's some things that can be used to make problems easier when we encounter them, but rarely would you have a problem where you would have to rely on this to solve it. So it's just basically would give you some shortcuts at some point, but not really be key to solving the problem. So if I have two parallel lines, cut by a transversal, that's just a line intersecting both of them. Okay, we have a lot of different angles that are formed. I'm going to number my angles, and it would be helpful if you drew this picture and labeled yours, numbered yours the same way. I feel like we need to get a big thing of hot chocolate, and then you guys could warm up your water and have hot chocolate.
Oh, you guys can use water, just not my coffee.
Oh, you could use the thing that's free.
Okay, if I talk about alternate interior angles. So what does alternate mean? Opposite. Interior just means inside the parallel lines. So inside my parallel lines would be here. Alternate means opposite sides. So it would be angle 3 and angle 6. Angle 4 and angle 5. So those are the alternate interiors. Angles 3 and 6. Angle 4 and angle 5. Do you guys know what is true about the measurements of those angles?
Negative goes right there.
So,
Oh, they are the same.
yeah, 3 and 4 would add up to 180 because they make a line, but since 3 and 6 are on opposite sides, they are actually the same, or congruent, equal measure. Alternate exterior. So we know alternate is opposite sides, exterior would be outside the parallel lines. And what would be true about those measures? They are also equal. Consecutive interior. So consecutive would mean same side. Interior, inside the parallel lines. So that would be 3, 5, 4, and 6. And these are sometimes called same side interior. I'm pretty sure Mrs. Dyer uses consecutive interior terminology. Okay, so if I wanted to know what was true about these measures, we know that 3 and 6 have to be equal. And 5 and 6 make a line, so that means 3 and 5 would be a line. So they are supplementary, they add to one another. So 1 is above the parallel line and to the left of the transversal. So we need the angle above and to the left. So it'd be 1 and 5. Angle 2 and angle 6. Angle 3 and angle
7.
and what's true about those measurements? Okay. Vertical angles. What does that mean? They're across from each other. So angle 1 and angle 4. They think about they're across from each other in an X. So 1 and 4.
2. Five and 8, 6.
And what's true about their measures? So in all of these special angle measures, they're, when you have those parallel lines, these angles turn out to be congruent, except consecutive interior, those are supplementary. Questions? Have you guys all seen these before? Okay. I am not ever going to ask you to label them, so I'm not going to pick two angles and make you tell me that they're alternate interior or anything like that. This is just useful if we are looking for something in a picture. If you remember these things, they can help you identify some measures. So let's look at this problem. I want to find the measures of angles 1, 2, 3, and 4 if lines M and N are parallel lines. We have to start the two angles I told you something about were 2 and 3. What would be true about the measures of angles 2 and 3? Those are supplementary, so they add up to 180. X plus 4 equals 180. Divided by 16, and we get 11. So I asked for the measure of each angle.
No, we put it in.
Remember, we can use M for measure. You have to put degree symbol. So on 2, angle 2, if you put it in, you get 99 plus 9. So 108 degrees. Angle 3, we plug in 11, 77 minus 5. 72 degrees. Then what would angle 1 be? And what about angle 4? Right. You could either say it's corresponding with 2, or you could say 3 and 4 are supplementary. So 180 minus angle 3 gives us the 180. that one? Second piece that we will use a lot. All the angles in a triangle add up to what?
180.
180. Triangle is 180. Like a square, rectangle, circle, those all add up to 360. So that is the second important piece from today. Probably even more important than those special relationships. The angles in a triangle add up to 180 degrees. Okay, so let's look at this one. Two measures in a triangle. We have an angle of 33 degrees, 12 minutes, and an angle of 26 degrees, 35 minutes. Find the measure of the third. So, probably a little bit trickier because I did degrees and minutes instead of just degrees, but what do you think we should do first?
Draw a
Turn it all into
picture.
degrees.
I don't.
Draw a
know,
picture.
I'm trying to-
I drew a picture first, I guess. But
You can 100% draw a picture if it helps you. Not required, but always a good strategy. We know one angle is 33 degrees, 12 minutes. We know one is 26 degrees, 35 minutes. Okay, how can we get the third?
so turn it all into degrees first. Or we can add those
Okay.
first.
Let's add them together. Good refresher from last week. So we add the minutes, that's 47 minutes. We add the degrees, so 59 degrees, 47 minutes. Remember, if we get more than 60 minutes, we have to convert it into a degree, but that didn't happen. And then we know they're supposed to add up to what?
180.
So we have to do 180 degrees minus what we just got.
Well, we can just go ahead and take one out,
Yeah.
convert it degree.
Convert 1 degree into how many minutes?
60.
So 60 minus 47. 179 minus 59. 120 degrees, 13 minutes.
If we start in minutes and we end up converting, do you want us to convert back to?
Yes. So the general rule I'm going to use is if I give you the original problem in degrees and minutes, I want your answer to be degrees and minutes. If I start in decimals, then I want you to answer in decimals. Alright. We can classify triangles based off angles and sides. So we use different terms if we're talking about angles and sides. If I say an acute triangle, what does that mean?
Less than 45 degrees.
Right. An acute angle is between 0 and 90. So to be an acute triangle, that means all angles are acute. Every angle measure is between 0 and 90 degrees. What's a right triangle?
90 degrees.
How many 90 degrees?
190 degrees.
Mm-hmm. And what's an obtuse triangle?
Between 90 and 180.
Right. Obtuse angle is between 90 and 180. You can only have one of those in a triangle. If you had more than one, it would add up to more than 180 degrees. Okay, if I say an equilateral triangle, what does that mean?
Oh, they're all sides of the same.
What's an isosceles triangle?
Two sides of the same.
And a scalene triangle?
One side is the same.
So,
I don't know my triangles.
there's 3 sides in a triangle. None of them can be identical.
Oh,
if
I
it's
guess one
scalene.
side is the same as none.
Yeah. I knew what you were getting at, but
I didn't actually take geometry,
it's
and
okay.
I don't know my
It's
shapes.
okay.
That's such a memory from first hour last year of like the thing going under the door.
All right, and then we have one final piece. So if I asked you to classify a triangle, you would use 2 words based on angles and sides. If you have one right angle and 2 sides the same, you would call the right isosceles triangle. If there's one obtuse angle and all the sides are different, you would say an obtuse scalene triangle. So you use both words when you're describing it. Final thing for today, similar triangles. What do I mean when I talk about similar triangles?
They're different sizes, but they're the same.
Yes. So, similar triangles, the corresponding angles have the same measurement, and the lengths of the sides are proportional. It's like you take a triangle and you blow it up. They have the same angles, but their sides are different. Alright, let's look at some problems involving similar triangles, and then that'll be where we stop for today. So in this figure, triangles DEF and GHI are similar. Find the measures of angles D and E. One thing to be careful of, when we're talking about similar triangles, you don't want to look at the picture and try to guess which angles are the same. You want to look at these statements because order matters. So the way this is written, that means angle D and angle G would be the same measure. Angle E would be the same as angle H. Angle F would be the same as angle I. So, the measure of angle D, I know would have to be the same as G, so that would be 98 degrees. The measure of angle E has to be the same as the measure of angle H, so 39 degrees. So make sure you use the statement given. Don't just try to look at the picture and guess. Order matters. I mean, I feel like
It's fine.
just being an underachiever at the moment. Alright. So, given that triangles MNP and QSR are similar, find the lengths of the unknown sides. So I gave you all the lengths in this one and only one in this one. So I have to find each of these 2 sides. So I call this X for a moment. If the triangles are similar, we wrote down earlier that they are proportional. So that means I can set up a fraction. So I could say like x over 12 equals, and then I have to pick the corresponding sides in the other one. So side x would correspond to side 10. 12 would correspond to 8. So x over 12 equals 10 over 8. Then how do we solve that? Multiply, you can multiply 12. A lot of times people cross multiply. Doesn't really matter, depends on how you set it up, what you need to do. So x is Did I give you any measurements here? No, so we can't put units. But if I did, you could include those.
Can we like
Wait,
just
so where-
automatically put degree, oh no, that's the outside.
Yeah.
Where does the 15 come from if there's not 15 in the first one? Or is it just everything increased?
Yeah, everything
Okay.
increased. So if I wanted to find this side, tell me a proportion I could set up to find it. Okay, I heard 12 over y first, but you could do y over 12. If I did 12 over y, what would that be equal to?
8 over 12.
Do you think it's corresponding size in each triangle? So 144 divided by 8.
18.
Is that okay? I have one final, maybe two final ones. Samir wants to know the height of a tree in a park near his home. The tree casts a 38-foot shadow at the same time as Samir, who is 63 inches tall, casts a 42-inch shadow. Find the height of the tree. What do I do?
Draw a triangle.
Draw a triangle.
I don't know how we get a triangle, but you draw one.
Well, so we would assume the tree is vertical. And where does your shadow go?
Down.
On the ground.
On the ground. So let's assume this is a right angle. Okay, we don't know how tall this tree is. His shadow is 38 feet.
Yeah, regular
Maybe
units.
it's
Regular
special.
units.
Okay. So hold that thought for just a second. We also have Samir, right? So this is the tree over here that we're measuring. And then I am very artistic. So here's Samir. And he is 63 inches tall. And his shadow is 42 inches. Okay, so what kind of triangles do we have? They're both two right triangles. Since it's the sun at one point in time, on both of them they would be similar. So first question is, do we have to worry because some of the units are inches and some are feet? And it actually only matters if we have different units in the same triangle. So as long as this whole triangle is feet and this whole triangle is inches, it's okay. We don't have to convert them to match. So we just have to set up a proportion. What would we say?
X over 63.
Different ways. So if you said x over 38, you would say equals 63 over 42.
Why do we have an X over 6?
So somebody said that first, and I was going to finish it that way. But different ways.
Fine.
If you, so here, I'll write them both down. If you did x over 63, you'd say 38 over 42.
Oh.
Mm-hmm. So, doesn't matter. You'll get the same answer. So we get x to be
57.
57. And since that was the tree, that one would be measured in.
It was easier than I thought.
Good.
I was really lost on the first one. I realized you just do that. Like that one, that one,
Mhm.
that one.
That'll work. Do we need more practice with any of this? And let's